Welcome to ClickMyProject.com. Let's discuss about the project parallel network file system using authenticated key exchange protocol. Abstract. Let's discuss about the abstract. Parallel network file system is a new standard part of network file system version 4.1 standards. Network file system version 4.1 that follow request for commands RFC. Files 662 is a minor release of a network file system version 4. Network file system version 4.1 does not modify any network file system version 4 features and functionalities. This paper describes an architecture for a secure file system based on network attached storage that guarantee end-to-end encryption for all user data. We describe the design of this system focus on the features that allow it to ensure that data is written and read only by the authorized users. Even in the face of attacks such as network snooping and physically capture the storage media. In this paper, existing system we use a Kerberos-based parallel network file system protocols. Many of the practical issues faced in implementing robust Kerberos security in a Unix environment can be easier by using a window active directory system. The existing had some drawbacks. It not be feasible to provide store physical security and network protection for all the storage devices. So we propose 3 authenticated key exchange protocol for parallel network file system. It is not an attribute of the data but an arrangement between the server and the client so that can still be accessed via non-parallel network file system and other file access protocol. Parallel network file system benefit workload with many small files or very large files, and it's suitable for a range of HPC types workloads. Data flow diagram. Let's discuss about the data flow diagram. Start the program. Storage device generate the secret key and GSI. GSI key used the Diffie-Hellman algorithm to generate the GSI key. These keys are encrypted and then storage devices ID are attached to sender server. At the same time, the client generate the secret key and GC used the Diffie-Hellman algorithm. GC and GSI are the two prime numbers, and these keys are encrypted and attached with the client ID to send server. The server receives the storage devices message and client message and then decrypt the keys and storage device resend the keys user and storage devices ID Diffie-Hellman keys GC and GS and validity time are encrypted to send the storage devices and then storage devices GSI key and secret key of the client encrypted to send the client. If the client receive the secret key and client receive the secret key and send the request for server. That request message attach the client ID and storage devices ID. And the server generate the validity time and send to the client. If the client encrypt the validity time and secret key and the validity period to send Storage devices. Storage devices receive that request and check the client ID is valid, and then if valid, and then check the validity time. If the validity time is valid, encrypt the session, generate the session key and encrypt the session key and validated period to send the receive client. If that user ID is not invalid, and time is invalid, not send the session key, and then display the graph. Graph is used to display the performance of the key generation time, and then client receive the session keys and time. Check the validity time. If the validity time ended, session key not work, and then client resend the keys in phase 1 automatically generate. Otherwise, the client data receive. Otherwise, the client transmit the. Let's we discuss about the authenticated key exchanging protocol. Run the client and user program. First, the user get the personal details of the user ID and see GC is the healing algorithm used to given the CG key. CG key is the one type of the secret key, and then KCM is the secret key, is the known as the user and storage device ID, and then user enter the secret key and then validate. If the user and then user encrypt the secret key and GC key say encrypted to send the server. If the server receive the secret key and user key and then user ID. User ID is the unique. If the server validate the user ID, so view the receiving message and decrypt and analyze the user ID and secret key, and then server send the storage devices ID and validated time and server storage devices session and the filling key, and then encrypted to send the user. If the user active to receive the message, the server send the message to user. User receive and view the message and then validate. If the key is valid, the user enter the ID and user ID and the secret key. These are used for validate the key is receiving key is correct or not. If the correct original key is retrieved, encrypted to retrieve, and then user get the which storage devices are here accessed, and then that storage devices ID and secret key, and then user ID and secret key are encrypted to send the storage devices. Here storage devices is the act as the servers are acted as the storage devices, and then the storage devices receive that key and then generate the session key. If validated time is changed, and then storage devices send the particular file to server user particular file to user. If the user receive the file before he validate the session key time, if that time is validated, enter the secret key and then receive the file. Then the server validate the session key is valid or not. If the time is closed, the session key is ended, and then display the graph for use to the compare the overhead of the existing proposed system. The proposed system increase the overhead of the existing system, increase the authenticated and third party hackings.